unicellular, and then we started having multicellular. So if we talk about amoeba, parasites, bacteria, they were the first to come, and then complex structures, like even among the invertebrate, they started appearing. Can I have the next slide, please? So let us have a look on the Earth. How does it look like? So Earth is combination of three broad layers. At least this is what visible Earth. Okay, there is an invisible Earth also, which is called Earth interior. But what is visible to us is a combination of atmosphere, hydrosphere, lithosphere. Now, all of us are living on lithosphere, and we have huge water bodies around us, which is called hydrosphere. And then something above us is atmosphere. Now, these three together are making life possible in various combinations. So what we are saying, if we have to call them collectively, we are calling them biosphere. Okay, so biosphere is all those places where life is possible. And we know that there is life in different parts, and we are, of course, terrestrial living, but then in water, there is life. In different other parts, there is life. Can we go to next slide? So let us first see that 2 or 3 elements what we discussed. Of course, water, oxygen, which are the 2 main criteria of life on Earth. And then sunlight is available to all the planets, but it helps us because we are in close proximity. If you compare our position in terms of Saturn, Jupiter, Neptune, we are closer to the sun, and so we get good temperature range. So sunlight, good temperature comes from there. But when it comes to water, like some of the other planets, we were also not having water when Earth got formed. And I hope all of you know that we are a planet with nearly 4.6 billion years of history. So Earth of the age is 4.6 billion years. I hope you understand what is billions. You see, if you read newspapers, there are people, politicians who are talking about millions and billions. But in terms of history, if you think the average human life being 70, or let us, for our simplicity, count it 100, then you see how many generations of human being would have been if Earth is that old. And when it got formed, it was a dry planet. There was no water, no ice on the Earth's surface. But there are evidences that there have been continuous showering of various meteorites, asteroids on our planet, especially in the initial part, and that is more than 3 billion years ago. And that is how we got water. So asteroids brought ice sheets, which on the temperature of Earth got melted, and we started having water something around 2.6 billion years ago to 3 billion years ago. Can I have the next slide, please? I hope all of you are familiar with this cycle. So there is a continuous flow of water from ocean to atmosphere and coming back on the lithosphere and then going back to the ocean. And this process keeps on happening all the time. And of course, we will discuss a little later how and what it is. But this water cycle does not mean that water is perennial. We may have our own challenges. And that is why time and again, people have been advised that you need to be careful with the water. Don't waste water. Don't pollute water. I said earlier how we have polluted our rivers. Even our oceans we have polluted. We have put plastics over there. So many sea animals are dying. We need to be careful. We need to be cautious. Can I go to next slide? And if you see how much water we have got. So Earth has got nearly 70% of Earth is covered by water. Okay? But out of that, only 2.5% is fresh water. Rest, 97.5% water is alkaline water, sea water, which is not good for the purpose of drinking, is not good for food, is not good for other purposes, even washing your clothes, is not good for irrigation. So we need to remember that whenever we are talking about water on Earth, it is only 2.5% of the fresh water we are mostly worried about. Of course, we are worried about the seawater also, but then 2.5% is the fresh water. Now, if we see the total fresh water which is available to us, it comes in 4 major categories. Glaciers, which accounts for the bulk of it, then the groundwaters, permafrost regions, and surface and atmospheric water, which we see. So glaciers, I hope all of you are aware that poles are our biggest friend, and we have got Antarctica here, which has accumulated huge mountains of ice, glaciers. There are some other regions, especially the Nordic regions, the northern part close to northern pole, where we have got huge ice sheets. And then there are high altitude regions like Himalaya, where we get ice sheets. But then there is a difference. Himalaya does not have snow all time of the year, except in some parts. Okay, some of the peaks will have all the time because of their altitude, but many of them may not have snow all the time. But Antarctica, Nordic region are having snow most of the time. Groundwater is a rich resource. As you can see that 30% of the available fresh water is groundwater. But again, we have been very, very greedy, and we have misused, especially in several cities, urbanized, in the process of urbanization, for the purpose of construction, we have overdrawn the groundwater. And many of cities, including Delhi, Chennai, some other cities, are listed that they are not going to have groundwater in time to come. And we have going to have a major challenge. Then we have got surface and atmospheric water. Now this is a water what we are seeing most of the time in our rivers, during our rains, and in different drainage system. And that is the water which comes to our home. Only 0.4% of the available fresh water on the Earth's surface. Can you imagine how small it is? And then when we are talking of this surface and atmospheric water, it is in the form of lakes, moisture, atmosphere, wetlands, biota, and rivers. And remember, wetlands are important. They were the primary reason why we are here today. The life started from these wetlands. Very important. Okay, next. Next slide, please. Now, second important component is oxygen. So how did oxygen came into Earth? So as I mentioned to you, nearly 2.6 billion years ago, we got ice sheets with the asteroids, and soon thereafter, we had life forming on the Earth. The unicellular animals started forming, and there was something called cyanobacteria. I hope all of you, before I go into this slide, all of you are aware that nature has created a very unique balance. Like if we are consuming oxygen, then nature has created plants which are releasing oxygen. If we are releasing carbon dioxide, there are plants which are consuming carbon dioxide. So similarly, nearly 2.4 billion years ago, this microbes, cyanobacteria, released oxygen as a waste product, and atmosphere started getting richer and richer. And how long it took? Nearly a very long time. 2.4 billion years ago, it started producing oxygen in a smaller quantity. But then life in a complex form started developing nearly 540 million years ago in a period what we are calling as Cambrian. So anything before 540 million years ago is Precambrian. They are simple form of life. So we have unicellular element, and now with the help of cyanobacteria, we got this thing. Now, these bacteria are very, very tiny creatures. You can see only under microscopes, also known as microbes. And right now, there is another microbe which is making our life miserable, the COVID. We can't see. Okay? So microbes of the very, very small size can also make difference, both constructive and destructive. And this cyanobacteria gifted Earth with oxygen and enriched it. Of course, all the Earth processes are very, very slow. So it took pretty long time, and the first complex life started coming 540 million years ago. Now, I hope you are aware that man or human being started on this planet not very long ago. If you compare the history of the Earth, then it looks like that human being came on the Earth just yesterday. So we are there for nearly 10,000 years. But before us, there have been very, very different kind of species which have come on Earth, gone from here and taken off. Now, with oxygen, the another important cycle is carbon dioxide. Can we go to the next slide? So Earth has to maintain the carbon balance also. And while there are many sources which we are creating, the absorbent are the plants and seawater. They absorb carbon dioxide. But then whatever we are doing, like deforestation, soil decay, respirations, our respiration is a normal process, burning plants, volcanic activity, fuel consumption by automobiles, by industry. So we are releasing carbon dioxide to the atmosphere. Now you must have heard that we are polluting our atmosphere. Now this is this imbalance which we are creating. So whatever carbon dioxide could be absorbed by plants and by sea, if we are releasing only in that quantity, then it is fine. But if we increase anthropogenic activities, if we increase human efforts, if we increase several other activities, we are disturbing the carbon balance on this planet, and which will cause several other consequences, including what we are calling climate change. Can we go to the next slide, please? So before I move further on this carbon front, just to tell you that the beginning of complex life on planet is marked by a geological period called Cambrian. So for most part of the Earth history before Cambrian, life was in the form of bacteria, eukaryotes, and ultra simple plants. But with the beginning of Cambrian period, evolution started and life started in the form of brains, eyes, and skeleton. And first, we got a lot of invertebrates. Of course, with progression of time, we started having more complex life on the earth, including life in the sea, life on the land, and the amphibians. And you know, we had got even gigantic animal like dinosaurs on the earth. But of course, because of earth processes, several forms of life have come, gone, and there may be a time when human beings are not there on the earth, because the way we are treating our earth may also treat us. Next. Now, just to give you an idea about the atmosphere, of course, I have put even 8 layers, but you can broadly call it troposphere, stratosphere, mesosphere, thermosphere, and then there are boundaries in between. Now, red line shows here the temperature, which says that each alternate thing is reversal. So like troposphere, we keep on getting higher and higher temperature as we go up. But when we enter into stratosphere, temperature starts coming down and then goes up. So it keeps on varying. 2 or 3 things are very important. One is presence of ozone in its stratosphere, which protects all toxic elements to come from outer surface, out of Earth, inside the Earth system, which is very important. I hope you are aware there was a hole called ozone hole, which is now being covered, which is now being looked into. Second important thing, if you see in the thermosphere, we have got aurora lights. Now, if you would like to see what is aurora lights, can you show me the next slide, please? What a beautiful sight it is. Aurora lights are also known as polar lights or aurora polaris. It's a natural display of Earth's sky, predominantly seen in high latitude region. And you can see it close to the poles. So aurora displays dynamic pattern of brilliant light that appears curtains, rays, spirals, or dynamo flickers. And why they are caused? Auroras are result of disturbance in magnetosphere, we'll discuss a little later, caused by solar winds. And these disturbance after the trajectory of charged particles of magnetospheric plasma. These particles, mainly electron, proton, precipitate into upper atmosphere, resulting into such brilliant display. Can we go to the next slide? Now, we have been talking so far how Earth looks like, what we can see or experience from our visible eye, by our own hands, or by several equipments. There is another part of Earth which we know only indirectly. And that part is called interior of the Earth. So, as I said earlier, that we are living on the topmost part called Earth crust. And then beyond Earth crust, there is mantle and then core. And composition of Earth is not same. It varies. It varies in terms of its position, like it is gaseous, it is liquid, it is solid. It also varies in terms of chemical composition or mineral composition. So as you know that all interior, we have got a lot of different materials. So broadly, if I have to say, Earth crust, we have got a lot of silica and aluminum. It's called Sial. In mantle, we have got silica and magnesium. And in core, we have got nickel and iron. Now, question comes, how do we know about it? Then I hope all of you would have heard about earthquake. When earthquake were studied, we started creating artificial earthquake. And we realized that there are two kinds of waves, primary waves and secondary waves. And with the combination of these waves and their frequencies, we can find out if there is a change in the state of matter, whether it is solid or liquid or gas, or if there is change in composition of the minerals. So these combinations help us in understanding the Earth interior, not only composition, but also thickness of each part. Now, this is indirect evidence, but we need to know something directly, because, as being a human being, we always need to confirm. We need to know if it is really true. But Our problem is that we can't dig that far. It is, if we talk about Earth core, it is very, very deep. How do we drill? Maximum drill which we have done so far is only about 10 kilometers. And that is not taking care of even the crust, which is solid. And the mantle, which is divided into two parts, upper mantle and lower mantle. Upper mantle has got lot of molten material. Now, molten material is something, it is between solid and liquid. Okay? Because of high temperature, we have got the molten, and there have been discussion that if we go and drill up to mantle, will it come out? And then what happens? So there is a problem. So nature has created another window to let us know what is inside. I hope all of you are aware about the volcanic eruptions, which helps us in understanding what is inside the earth. So volcanoes provide us another window to see what is it inside. Next slide, please. So one thing we must see that we are not a static planet. There are changes. Even Earth is not same everywhere. If you travel even 50 kilometers from your home, you will find variation in Earth. It may be in form of topography. It may be in terms of temperature. It may be in terms of weather. It may be in terms of vegetation. So Earth has got several possibilities, and it is not same. It is keeping evolving itself. Similarly, if you see life, it is also evolving itself in one form or the other. Next, please. So one of the things which we discussed a little ago when we were discussing the carbon balance, we are worried about climate change. Is it a recent phenomena? Is it a very new phenomena? Or it is part of the Earth history? When we study Earth history, we realize that climate change has been part of Earth system for very, very long. And very often there are so many reversals. So we call it climatic reversals, magnetic reversals. So Earth has got several episodes of climatic reversals. But as I said earlier, all Earth processes are very slow. They are slow in a form that you don't realize that it is changing. For example, if I tell you high elevation of Mount Everest is increasing, it is increasing at a speed of 4 millimeters in 10 years. Can you notice it? It's difficult to notice. Okay, it is only through our record books we realize that that is happening. So as far as climate change is concerned, our main worry is how much of it is through human efforts. Because the way we are adding more and more vehicles, the way we are adding more and more activities in creating pollutions, we are disturbing this. So what we are saying, that human beings are expediting process of climate change. So something naturally it would have taken 1,000 years, we are trying to do it in 200 years or maybe shorter. So that is a question of worry. Second thing is that if climate is changed, how does it affect the life? And when I say life, it doesn't mean only your and my life. It means life of the animals, life of the plant, and what you would be eating. Because mainly we are eating either from plants or from other animals. And if they are disturbed, our food cycle would be disturbed. And that is the major concern when we are talking about climate change. Can we go to next? Now, this is just a cartoon to show you. I think all of you might have seen mother in different moods. And she gets angry also with you. But remember, she loves you. She wants to see you progressing. But if you are naughty, if you are not listening to the house rules, she gets angry. Even Earth gets angry. Can we go to the next slide? Earth shows its anger in different forms, one of which is earthquake. Now, always, whenever Earth shakes, we ask why we couldn't predict it, why we didn't know. If I have done a mischief, I know my mother, she would be angry. If I do this thing, my teacher would be unhappy. She would be angry. Why I can't predict earthquake? Now, there are two kinds of things. One, where the next earthquake will come. Second, when it will come. With the understanding of earthquake pattern, now we have identified sites which are most likely to have earthquakes. But it does not mean that those places which are not shown highly vulnerable will not get earthquake. They may also get it. But wherever vulnerability is high, those places have been identified and we'll see it a little later. Can we go to the next slide? But timing of earthquake is still uncertain. It could come anywhere. And when there is an earthquake in water, it causes tsunami. Okay, so huge water waves will come. And I'm sure those of you who are from Tamil Nadu and Kerala, they would remember, either they would have seen or their parents might have told them that there was a tsunami that hit India. And we had a lot of after effects of this tsunami. So tsunami is a Japanese word because it is more common over there and they get a lot of tsunamis. And this is another way Earth expresses its anger. Other being cyclones, which are very common in our part of the world. Bay of Bengal receives cyclones very now and then. And of course, Arabian Sea is not spared out, but they also get. In other part of world, they get tornadoes. So there are a lot of water related things, but tsunami is caused because of earthquake, cyclones, and tornadoes are caused because of air circulations. Next, please. And then we have got volcanoes. Another way, Earth is unhappy with us. Okay, and as I said earlier, this are window to the Earth interior. Lot of molten material will come out of it, and of course it will create some new rocks, but it will disturb life in that part. And that is one of the reasons we are contemplating why dinosaur got killed. So what we feel that 65 million years ago, there was a huge volcanic eruption in our part of the world. We call it Deccan. So if you see part of Gujarat, Maharashtra, Karnataka, and even Andhra, they have got black soil. Even Madhya Pradesh. And this is because of the volcanic eruption that happened and which did not allow sunlight to come to Earth for nearly 3 years. Now, that is where most of the complex life like dinosaur got vanished. They could not survive without sun. You know, if sun is not there, plants will not make their food. And if plants will not make their food, where will a bigger animal get their food from? So it's a cycle. And if one parameter is disturbed, then it keeps on disturbing the whole system. Next, please. Now, these are the maps provided by USGS, United States Geological Survey, of earthquake and volcanoes. And if you will see that there is 70 to 80% overlap of areas which are prone to seismicity are also prone to having volcanic activities. But see, our own part, the Himalaya, we are not having volcanic activity over there, but we have a lot of seismic activity over there. So there are parts where we do not have both activities together, but majority of it, we are having them in overlapping area, one over the another. Next slide, please. I think it is already 3, we need to hurry up. So in the beginning, Madam told about plate tectonics. So this is another form why Earth is not same all the time, whatever we have seen. Can you go to the next one also? Yeah. So Earth, what we feel, has been broken. There was a supercontinent called Pangaea, and that Pangaea got broken into 2 major parts. Laurasia, the northern part, and the Gondwana land, the southern part, which was separated by a sea called Tethys. And then it got further fragmented, and we are seeing this is in the left map, the southern part of the continent, the Gondwana land, which has got jigsaw fit. So it is believed that they were together once. This is how we are reconstructing history. Because at that time, there was no man when this activity happened. So we are trying to see that if they are matching. So this is the first possible indicators that continents have been drifting. And we need to know how and why they are drifting. Can we go to the next slide? Now, based on the activities, we have identified that the Earth's surface, the crust, is divided into several plates which have been moving. So, of course, you have seen how they were fitting in each other, but then they are constantly moving. And the boundary of plates is not restricted to the continent they are representing, but that is much beyond them. So it goes up to the sea. A large part of sea also is on the. Now, what is happening? if we see India, we were in southern hemisphere, and then being southern hemisphere, we are called Gondwana lands. So in fact, there is a tribe in Madhya Pradesh which is called Gonds, and after them it came the Gondwana land. We have had a continuous move in the northeast direction, and today we are completely in the northern hemisphere. Okay, and because Indian plate was colliding with the Eurasian plate, that is how Himalayas are formed. And that is where we see lot of activities. So why, one of the purpose of showing you this map is that these plate boundaries where they are meeting each other, these are the places where we have lot of seismic or volcanic activities. These boundaries are called weak zones, where we could expect some kind of activities, some kind of release of energy, some kind of friction to take place. Next. Now, only geographical boundary was not adequate. There was a gentleman called Wegener. Can you go to next also? So Wegener said that there was some kind of life which was existing and they could not cross or sail the sea. So that is another reason why they must be connected. Now, if you see today, elephants are there only in India and Africa. And is animal as mammoth as elephant cannot cross the sea. So unless India and Australia were, India and Africa were together, they cannot move. So we are trying to find not only elephants, but there are so many dead animals. We call them fossils. So we discovered so many fossils and we observed these trends. As you can see that what are the fossils you can find in these parts of the world, which, and it shows once again that these planets, these continents were together at some time. Next. Another very important mystery of the Earth is its magnetic field. And as you can see that we have got nickel and iron in our core, which are responsible for this property. Of course, human has made good use, like earthquake, we use earthquake waves. Magnetic property also we made use of. We are using it in the navigation purposes, and we have created compass. So compass helps us pointing towards magnetic north. Now remember, magnetic north and geographical north are not same. Because Earth is tilted, we have two different things. One is called Earth geomagnetic field, and second is geographic North Pole. And this is primarily because we keep on happening this magnetic activities, which helps changing. Currently, there is a distance of nearly 11.5 degree between magnetic north and geographic north. And a lot of magnetic storms keep coming, keep disturbing several parts of the world. Next, please. Well, with all this thing in background, now we will go on a quick journey how Earth looks in different part, why it is not same everywhere. So I think this is a scene most of you would have seen daily life. Can we go to the next one? This is a frozen place. So you see a lot of snow. And if you see today, many part of Europe, many part of Canada are getting snow. Okay. And when it comes to May and June, even places like Australia, not Australia, New Zealand, they will receive such a huge snow. And one of the habitated area which is known to have lot of snow is called Siberia. You remember we get lot of Siberian birds into India who migrates during the winters because they can't bear that kind of climate, that kind of temperature. Siberia receives at some points even up to minus 70 degrees Celsius temperature. Of course, it gets even minus 40 is very common over there. Next, please. This is another site full of dust, full of bright light, and full of pollution. Okay, this is also our part of the world. We need to be more careful that we are not having such more and more such thing on the surface. Next, please. And these are another thing called floods, which is we get in several parts of our country. And we know some part it comes every year. But some other part, it comes surprisingly. It may be because of torrential rains. It may be because of cloud burst. But flood primarily means that the channels which we have for flow of water are not adequate enough to take the water away. And that is why we get floods. Next, please. And then lightning. You know, of course, in India, we do not see that many lightning, but there are recorded evidence that lightning strikes 100 times every second in one or the other part of the world, which means you can understand we have got in each microsecond, one lightning event is happening. Next, please. Now I'll take you more quickly to some of the interesting things. So this picture is of stalagmite and stalagmite. These are normally found in caves. Okay, maybe you remember why Amarnath Yatra is famous for? Because we are going for darshan of stalagmite. Structure like this. So what we are calling the snow linga is nothing but features like this. Okay, what happens when water is passing through a water-soluble rocks? It keeps on dipping, and that dips result into structure, linear structure like this. So what we are saying that stalagmite are upward growing mounds of mineral deposit that have precipitated from water dropping into the floor of a cave. And stalactite is other way around when they are growing from top to the bottom. Next, please. Well, this is a beautiful site which has been noticed only 10 years ago, the Siberian craters. Okay, and what they have observed that it's a gray jumble of ice and clothes of the permafrost region. So only in the permafrost region, Siberia is part of it, we have found that there have been some very, very noisy or violent activity, and this kind of craters have been there. And from the air, it says exposed dirt stand out against the green tundra and dark lakes around it. The layers of earth and rock exposed further inside the cylindrical hole are almost black, and a pool of water is already forming at the bottom. So this is something very, very new and has been noticed in 2013 for the first time. And we are trying to understand what it is. So many of these stories which I'm going to share, some are understood, some are not understood. Next, please. I think everybody must be knowing about this place called Bermuda. And this is a place where it is said that there are a lot of magnetic storms and there are high magnetic activity, and very often ships, aeroplanes are lost. Okay, there are counterclaims also, but this place is now called Devil's Triangle. And a lot of airlines and a lot of shipping company avoid going to this part of the world. Next, please. This is a nature's mystery. You know, there are 400 pines tree in the Poland, which were done by the men. So we men planted them, but nature has created their roots in such a way that they are now bent at 90 degrees. So these are 400 such trees, and we do not know that how they have bent northward and then backwards. And there are some very, very unnatural things. There are theories about this mystery, although there is very little or no evidence to support them. Some hypotheses say that a very unique gravitational pull in this particular area has caused the tree to grow curved northward. But this theory does not hold up basic scientific scrutiny, given that gravity pulls things downwards and not at a curve. Other feels that because of heavy snowfall in the area, it got weighed down as trees were sprouting, causing them to grow crookedly at the base. But this is very, very interesting thing which we see in Poland. Next, please. This is a Richet structure from Sahara. Now, it looks like a concentric ring, and how it would have created. There are beliefs it was a natural structure in the form of a dome which got eroded. And now we are seeing only the base. So igneous rocks are exposed inside in the center, and there are specular rhyolite and gabbros which have undergone hydrothermal alteration, and they have formed breccia also. This is something very, very unique in this part of the world. You find it in the Sahara. Next. Blood falls. This is Antarctica. So at a time when we are talking that Antarctica must be all white, all silvery, full of snow, we find that there is a fall with the red color of water. And this is called blood fall because it looks reddish on the white surface. So blood fall is an outflow of iron oxide tinted plume of salt water in eastern part of the Antarctica. So iron-rich hypersaline water sporadically emerges from small fissures in the ice cascade. The saltwater source is subglacial pool of unknown size, and this is falling at a height of about 400 feet. Next, please. This is another thing, another crater in Turkmenistan called Darwaza crater. You know, Darwaza, as we say in Hindi, means gate. And this is called gate to the hell. Okay. And lot of stories are there, whether it is man-made or natural. But there are rumors that it might have been started by the human being. And because of military rivalry, somebody has put it on the fire. And there is a constant flow of methane gas, which is keeping it live. But today, in Turkmenistan, this is one of the tourist point of attraction where you find huge area of nearly 5,000 square meter light burning all the time. Next, please. Eternal flame fall in New York. Now, if you see this fountain, this fall, below this, there is a light. A very, very unique structure in New York, absolutely natural. Okay. And this is how natural gas emitted occurring from the hydrocarbon seeps contribute to the greenhouse gases in the atmosphere. And it has been observed that the macro seep at eternal flame had higher concentration of ethane and propane than known other natural gases seeps. So it's a very small, but then it is there. Next, please. And these are fairy circles in Namibia. So fairy circles are circular patches of land barren of plants varying between 2 to 5 meters in diameter, and they are often encircled by growth of grass. So no life inside, but on the margin, we see it has got a lot of grass over there. Next, please. The Great Blue Hole, this is in Caribbean, and it is circular in shape, nearly 318 meter in diameter and 124 meter deep. And it has formed with several episodes. Several episodes of quaternary glaciation, where sea levels was much more lower. And these are primarily the stalactite which have taken the current shape. Next, please. And this is from Indonesia, where there are group of volcanic activity which is taking place in Eastern Java. And this is known for blue fire, acidic crater lakes, and sulfur mining. And what we see is the combined effort. And this is most highly acidic crater lake in the world. Next, please. When I say highly acidic, the pH is less than 0.5. So you can imagine the kind of acidity it has got. So next is Lake Abraham, And this is a very, very unique. It's a human wonder. So you can see that in Alberta, in Canada, they have created this lake. And what we are seeing in this picture are bubbles of methane gas, which are coming on. So most part of the year, this lake is frozen. And only in summers, we can see such a beautiful sight. Next, please. And this is Australia, the Lake Hillier. Here, very close to the Indian Ocean, we find a very, very pinkish lake. And you can see the difference between the waters, blue water versus pinkish water. So this lake is about 600 meter in length and 250 meter in width. It is surrounded by a rim of sand and dense woodland of paperbark and eucalyptus tree. The color is permanent, and it is mainly because of the organism present in water of this river called Dunalinia salina. So because of that, this color has come. Next. And this is Lake Maracaibo in Venezuela, which gets maximum episode of lightning. Next. So we saw the Indonesian lake, which is highly acidic. Lake Netron in Tanzania is highly alkaline. And it is so alkaline that pH value is more than 12. And so what happens if accidentally any bird or any animal that comes into this water is immediately dead? Next. This is my last slide. And here, of course, you can see a lot of human activity, but the focus is the water, which gets light in the night. And this is what we are calling it bioluminescence. So there are some phytoplankton known as dinoflagellates, which produces this light in the water. So these are some of the mysteries from the earth. I think this is my last slide, I suppose. Can we go to the next one? Yeah. So these are some of the mysteries about the earth and various processes of the earth we could have discussed in this limited time of 1.5 hours. And I don't know, if time is permitting, we can take on questions, but if time does not permit, you can write down to them and write down those questions, and I'll try to answer through email as early as possible. Over to the Science Foundation team.
Thank you so much, sir, for walking us through such a beautiful presentation and showing us images of different parts of the earth, which we may not have the opportunity to go and explore right now, but hopefully all of us at some point can do in the future. But
I have a suggestion.
Yes,
that you can Google them out. You can read more about them, how they look like, what is the color, and what are the different factors contributing to that aspects.
Yes, definitely, sir. I'm sure our students will read up and follow through more of the sessions that they have addressed. Particularly when you said Earth is our mother, and I know you spoke very passionately about it. It reminds me of one of the verses in the Atharva Veda. I'm not sure how many of you have read this particular verse. You can always Google it. But it says, the earth is mother, space is brother, and sky is our father, because nature was viewed as a combination of all these components that beautifully are woven together. Like the sky gives us the energy of the sun, Space gives us, air to breathe, and the earth gives us nourishment. So it's a beautiful, sort of explanation in a very poetic form of just what Sir sort of spoke through and ran us through it, and also how this, if there's a disturbance, like Sir said, if there's a disturbance in one part of this web of existence, the balance will be upset. With a corresponding disturbance somewhere else, not just in the outside world, but in the inside world as well. And it can affect us as well. Like, for example, if you take earthquakes, like Sir said, where if your mother gets angry with you, you sort of, there will be repercussions. The same way nature, it gets angry with us at sometimes, but it doesn't stop providing for us, right? But that doesn't mean that we sort of take advantage. It's important for us to take care of nature, because nature will eventually take care of us. Thank you so much, Sir, for such a wonderful session. We've had a lot of questions coming through. Unfortunately, due to time constraints, we will not be able to address every single question that you have, but we have managed to pick a few questions that I found interesting. Most of the questions that you've asked us actually already answered in through his presentation. I will just read out some of the questions right now, and Sir, if you would be happy to answer them, just a few questions. Siddhima Srivastava, are you there, Siddhima Srivastava? Okay, so her question was, what is the Arctic mirage or mirage?
Yes,
yes, mirage.
What is the?
Siddhima, you can I'll just unmute you, Siddhima, and you can ask your question. So, Sir, Siddhima's question is, what is the Arctic mirage?
Okay. Arctic mirage is basically a illusion, you can say. Mirage, as we know, is an illusion, and it is caused because of variation in air density. So in our day-to-day life, we see in desert, like if you are walking through, you feel like there is water, oasis. So that is called desert mirage. So you feel that there is something, but when you go there, you find sand and sand. Similarly, in the Arctic region, where air density increases downwards. So in desert, it is increasing upward because temperature is rising. Here in Arctic region, it goes downward. So what happens very often, we will see that real object far below the actual site. So this is the Arctic mirage.
Okay, sir, thank you.
Thank you, Sir. Thank you, Siddhima, for asking your question. Our next question is from S. Kashyap. Kashyap, are you there? Please unmute yourself. Okay, so I'll just state Kashyap's question. Kashyap's question is, will shifting of the magnetic poles cause threat to life on Earth?
Very interesting questions. There are a lot of variations, lot of movement. We are calling them magnetic storms, which are affecting our day-to-day life. But over the period of time, what we have noticed, that magnetic reversal takes hundreds of years or maybe thousands of years in changing its polarity. So in our lifetime, if we are very lucky, we will see only one case. And if we are not lucky, we may not see the reversal of magnetic polarity. But I'm sure it will change. It will have its impact. A lot of orientation would be changed, but life will continue as it is.
Thank you, Sir. Our next question, a lot of students have actually been asking this question, Sir, is how do they pursue a career maybe in geology or earth sciences? How do they go about doing this?
Okay, Earth, as we discussed a little ago, is a very, very beautiful subject, and a lot of time it is connected with the society. And economically, we are focused towards the mineral resources which are stored inside the earth. And with the application of geophysical tools like seismic waves and some geochemical studies, we can find out in which part of the earth, at what depth, in what directions, what kind of mineral deposit is there. So this makes geologists very demanding in economic industry, especially that of hydrocarbon, oil industry, gases, natural gases, and also several mineral deposits like copper, iron, aluminum, zinc. We have got huge demand. Of course, there is academic interest. People also want to understand different why life forms are changing. Like there is a saying, old saying, that if you are short of money to run a class in geology department, just run a public awareness course on dinosaurs and you will get enough registration. So because people want to understand how a creature like dinosaur could rule the earth and could go out of earth. So we need to understand how various processes of earth, and of course, it is closely connected with geography, which is related to the social aspect. How natural processes like rainfall, like floods, like drought, like snowing is affecting not only human life, but also the vegetation. How it is affecting life of various wild animals. What kind of plantation we can grow. So geography and geology go together. And then of course, if you are a nature lover, you can have a career in geology.
Thank you, sir. We hope a lot of you actually take up earth sciences. Another question that is that I see in the chat box quite often is, what is permafrost?
Permafrost is a region which is frozen most part of the year, and it completely remains frozen. So temperature in that part is never more than 0 degrees Celsius. So it is always less than 0 degrees Celsius. We find such region close to the poles. So permafrost region is very, very close to the pole. So not absolute pole, but just before that.
All right, sir. Thank you very much for that. Sanvi Singh from Bluebells Model School. Sanvi, could you please unmute yourself and post your question? Because it's quite a big question, so I would like you to sort of.
Yes, ma'am. Now I am able to unmute myself.
Okay.
So yes, ma'am, my question was that, just a second, ma'am. Just a second. Yes,
Sure,
ma'am,
sure.
my question. Yes, ma'am, my question goes like this, that ma'am, we all have known about the Big Bang Theory, right? And
You
ma'am,
all have known about?
Big Bang Theory, sir.
Big Bang. Okay, okay, yeah.
Yes, sir. Big Bang Theory. And sir, we also know about the creation of Earth, that how it was created. It was actually a rock which was floating in our solar system at first, and then it actually took some gases from the space, and then it like had layers upon it, right? If I'm not wrong. according to my knowledge, right? And sir, most of the planets have been made like this itself in our solar system. But sir, my question arises in here. Then, if all of these planets are like formed like in this way, then why there are like certain planets, like why they are divided into certain planets like in certain categories, like the terrestrial planets of our solar system, which are Venus, Earth, Mars, and the gas giants, which are Jupiter and Saturn, and the ice giants, which are Neptune and Uranus. So my question goes like this: that
Okay.
if they are formed in a similar way, then why are they different from each other?
Yeah, fine. Imagine you are sitting at the rooftop, and you are throwing things with your full capacity. Okay. Whatever be the heaviest will be staying very close to you. You cannot throw it very far. But something which is lighter, which you can handle with your weight, could go very far. So that is why we see that planets, mostly the solid planets, are close to the sun. And lighter planets or the gaseous planet are away from the sun. Now, only proximity is not enough, because only weight is not enough. Density of the particle is not enough. Other parameters also play. Like if you are close to the sun, you get a very high, you are exposed to a very, very high temperature. And if you are away, you do not get that kind of temperature. So that is why we see Neptune is always frozen, because sun rays, by the time it reaches there, they are so feeble. On the other hand, we have got red planet because of its proximity to the sun. So what has happened that coincidentally, Earth has been presented with a very, very unique set, that whatever asteroid falls brought water on the surface, Earth has been able to sustain it for a very, very long time. So it came 2.6 billion years ago, and Earth has carried it. On the other hand, some of the gaseous planets, they are having water, but it's a frozen water. Frozen water will not support life. It has to be liquid water. And Earth has got. So we are at a distance from sun where we are not getting burnt, where we are not getting melted, but at the same time, we are finding this temperature to be modest to support life on this planet. Now, I wonder if I have answered your question.
Yes, there are a lot more questions coming in. A quick question from Sparsh Dua. Sparsh, can you unmute yourself and please post your question? Otherwise, I will read it out. Sparsh, can you hear me? Am I audible? Please unmute yourself. Okay, so I think I will just read out his question. So the question is, we know that...
Yes, ma'am.
Okay, yes, please, Sparsh.
Yes, ma'am. The question I would like to ask is, we know that the Earth's outer core is solidifying at the rate of about 1 millimeter per year. However, scientists have also discovered that the eastern outer core is solidifying faster than the western. I would like to ask, what could be the causes and effects of this expansion? Scientists have also predicted that due to the solidifying of the core, Earth will lose its magnetic field in about 1 billion years. How would this impact life on Earth when this happens?
You know, you have answered it in the last sentence. If you can read it again, you will know the answer.
However, scientists have discovered that the eastern outer core is solidifying faster than the western. What
The
could
last
be
line.
Scientists have also predicted that due to the solidifying of the core, Earth will lose its magnetic field in about 1 billion years.
In about 1 billion years. And what is our life?
Sir, it could be that there are other animals on Earth apart
No,
from...
obviously. I'm not saying the life will go. What I'm saying is even human may be there. This is such a slow process. It will take about 1 billion years. So we are, to be very, very honest with you, are not concerned about life after 1 billion years. We are more concerned about life after 100 years, 1,000 years, million years, because these are our short-term and long-term concerns. Nature has got, as we discussed earlier also, that there are episodes of magnetic reversals which will impact, and it will happen, and it will not be uniform on all over the planet, because even today we have got heat or warm weather in some part of the world, cold weather in one part of the weather, extreme climatic event in several parts of the world, and then no activity or absolute dull weather in some other part of the world. So Earth is very unique. It's not uniform all around. So we expect that this reversals would also be not be uniform. It would be different in different places, but process is so slow that you will not notice it immediately. We have to see how it is going to affect us in a long-term vision. So if we read history of the Earth and see the biological events that have taken place at the time of magnetic reversals, we are not unduly worried, because life will continue. It would have some impact, but it will continue.
Thank you so much, sir. So the last question that I would be asking on behalf of most of the students today is, what is your take on evolution? And do you think that humans will evolve in the near future? It's a personal, subjective question.
No. Yes, of course, it's a very, very subjective question. Life on the planet has been evolving, and each new species that appears on the Earth comes probably with the God's message that since Earth has changed a bit, I am creating another species that will survive here. But then we all know some species survive for few moments, like insects. Some other species will survive a little longer. And we hope, like human being, we are here for 10,000 years on this planet. And we, unless there is some very, very catastrophic event which makes the life difficult. Now, I'll give you an example of a storm. What happens when a storm comes? Trees which are hard and rigid and strong, they get uprooted, but softer plants survive. So if any of the catastrophic events happen, the complex form of life would be challenged. The simpler form of life will continue. I hope I have answered.
So that was a very interesting take of how, the basic forms of life will obviously have to flourish to give a chance of future evolving species to evolve further. Yes. That brings us to the end of our question and answer session. I do know that the chat box has been bombarded literally with so many questions and messages. We obviously, due to time constraints, we can't answer every question, but thank you so much for posting all these questions in the chat box. Like Sir said, you could always send him an email if you have any further questions. You can also check out your answers, do more research and find the answers and sort of note down your observations as well and what you think is the answer to many of the questions that, you know, the other students have posted as well. Thank you so much, sir, for such a lovely session. We really appreciate the hard work that you do in this field of earth sciences, and for actually spreading this knowledge to the children who are interested in this particular field. Like, a lot of children wanted to know, how do I go about becoming a geologist? Or, you know, if I want to explore more in the field, how do I go about it? And I think that
one could go, because there are regular classes both in IITs and in universities as far as education is concerned. So you can do graduation, master's and doctorate, and then you can practice geology as a professional.
Yes, so we hope to see a lot of geologists in the future from this batch. You have a long way to go, but you'll get there someday. Thank you, sir. I'm sure you've helped a lot of our students gain clarity on concepts that you explained, especially with regard to the tectonic plates and at the core of our, what lies at the core of our Earth, because those were recurrent questions as well.
Yeah.
If Suhasini, if you could please go on to the next slide. Yes, so please, students, let us know what you thought about the session today. You can like, share, comment, and follow us on these pages. Post your questions. You can send us an email. We will forward it to sir, and we will get back to you with his responses. I also want to encourage you to mark your attendance in the Google form that has been shared with you. It's important for you to mark your attendance on the Google form that has been shared. It's been shared in the chat box as well. So kindly do that. And the next session that you have will be on the 15th of Feb. And the topic for that is climate change, the emphasis on polar frontiers. That is at 5 p.m. 15th of February, 5 p.m. will be your next session. And the topic for that is climate change. And I hope to see all of you there. Suchita ma'am, would you like to say a few words before we conclude? If you're...
Yes.
Yes, ma'am.
Good evening, sir, once again, for that very, very insightful session you had been sharing all this while. In fact, you know, you spent a period of 2.5 billion years or more from the time of the formation of the Earth to the process of evolution to what's inside and outside the Earth and what's impacting the Earth. But what I would like to tell you, kids, is that, you know, you don't have to go very far to understand anything. You have to just peep out of your window. You have to just see through your window to find out what Mother Earth is all about. You can just go and feel a stone to find out what is the composition of the soil which is outside your courtyard. So probably these kind of sessions cannot give you a complete insight of what it is. We are here just to trigger your passion and curiosity. We are just here to, you know, just kickstart the thought in you. You know, so marvelously, you know, touched upon all the various aspects. Now, please start dreaming about it. Please start thinking about it. Give you conclusive answers. Your textbooks do not give you conclusive answers. No YouTube can give you complete answers to anything, but there is something which can give you complete answer. That is your ability to think, the ability to research, the ability to find solutions. So that is what we aspire from all of you. You know, you had been so very well patient all the while, you know, and as Shivan mentioned, the chat box had been bombarded with your questions and doubts, which is very, very engaging. And I'm sure you would reflect from Sir's session. Whenever we had sessions from Sir, we have realized that, you know, there is so much of warmth and there is so much of connect in the sessions, which was very much there today also. And I'm sure you all are quite new to this branch of science. Though you study earth science from the very, very elementary level, you generally don't study a subject called earth science as such, though you study biology, physics, chemistry. But, you know, you study from as a multidisciplinary subject through all these physics, chemistry, biology, and geography, whatever you study. So there is a lot of opportunities. Start looking into you, what is your passion, and that is why we organize such kind of sessions. And more importantly, you are, you know, going to face the Spot 100 assessment examination. Definitely, there are going to be a lot of questions which would be from this. So I'm sure that you would have listened to this properly and reflect upon it, and go again and again through Sir's lecture. It's definitely going to help and benefit you. So with that hope and with utmost gratitude to you, sir, for your wonderful time you have spent. I know you travel quite a lot. You attend quite a lot of governmental engagements, programs at various capacities from the university level down to, these are 6th grade to 8th grade learners, down to 6th grade learners. So that is the span of learners you address, and I'm sure they're going to remember and cherish the learning what you have given today to all of them. So we at BSSF is extremely delighted to have you back once again. And I'm sure kids will start thinking, whenever you see in nature, you start think about it. Let me also request you one more thing. Don't Google all the time. When you see something, try to challenge your brain. Ask questions to yourself. Once you're unable to find it out, then you search out. Here, what happens many a time is before even the question is over, you are trying to Google and find out. So you're not challenging your brain. Thinking happens when we challenge our brain. So start doing that. Give a time for the brain to respond to your question, and then you proceed with anything. I'm sure you all will be able to do wonders through science. Sir, thank you once again, and I hand it back to Siobhan.
Thank you, ma'am. Thank you so much, everybody, on behalf of BSSF. We thank you, sir, for joining us. We look forward.
Yeah, my namaskar to everyone and good wishes. I hope I have generated some curiosity in you to understand our Mother Earth. And remember, as I said in the beginning, if you understand your own mother, you will also understand Mother Earth. Thank you.
Thank you so much.
Agree with that note, sir. Absolutely agree with that note of yours.
Yes,
Okay.
so that was very beautifully put. And I think that's something that will stay with all of us as we grow to understand our own mothers and Mother Earth eventually. Thank you so much, dear students, for joining us today.
Okay, bye for now.
Bye, sir. Thank you so much. Thank you, students. We will be seeing you on the 15th of Feb, as you can see on your screens, for our next session at 5 p.m. on the topic of climate change, with a special emphasis on polar frontiers, because our keynote speaker, Dr. Ruturaj, is an explorer who has been to the polar regions. So stay tuned for that, and we will see you on the 15th of February. Thank you so much.